Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutewa Sos Ukobela Wemet. And without any further ado, let's look at this question that we have here. Okay, so we have question 3, and we are still on Newton's second law. It says a force of magnitude F is applied to a 100 kg box at an angle of 60 degrees to the horizontal. The box is initially at rest on a rough horizontal surface. But now they introduce a new statement just below the diagram. They say there is a constant kinetic frictional force of magnitude 6.5 newtons. So which is telling you that the block is no longer at rest, right? So whatever that they just said here is no longer applicable because now there is constant kinetic frictional force, which is telling you that the box is now already moving. That acts on the box as it moves along the surface. So you can see that the box moves to the right. The box moves to the right with a constant acceleration of 5 meters per second square. 3.1. State the definition of kinetic frictional force. So we say kinetic frictional force is the force that opposes the motion of a moving object relative to the surface. So that's how you are expected to define it for 2 marks. Then 3.2 says calculate the magnitude of force F. So before we can calculate the magnitude of force F, let's first draw a free body diagram indicating all the forces acting on the 100 kg block so that we are able to calculate properly. Then this is the normal force going up there, and then down here we have the gravitational force. But then note that our force now is being applied at an angle, so it is being pulled at an angle. So we can just resolve this into components by saying here we will have our Fx, which is the horizontal component, and then up here we will have our vertical component, right, Fy. So note the way to just resolve this into components is just to close off this. Remember, this is in the first quadrant. Your x's are going this side in the first quadrant, and then your y values are going upward in the first quadrant. So that's just how you do it. And then we know that these two components will be representing the same effect of the resultant vector here. Now, acting in the opposite direction of motion, we know that is our kinetic frictional force. So just like that, we have drawn everything there. Now, because this is not this is not moving at a constant velocity, let's just show that our kinetic frictional force is somehow smaller than the Fx, right? So now let's calculate. We want to calculate the magnitude of force F, but then note that here we have the horizontal component of force F. So how are we going to use that to calculate force F? We can just go F net is equals to MA. So note that I'm solving 3.2, and then this becomes the positive direction since we do understand that it is accelerating to the right. Then this here is negative direction, so that means our equation is Fx minus Fk, and then is equals to Ma. So where are we going to get the force F? From breaking down this Fx. Remember, Fx breaks down to F cos theta, right? So we're just going to break it down here. F cos theta minus Fk is equals to mass times acceleration. Now our force we do not have, but then this is cos 60 degrees, the angle of the force, and then minus our Fk, we are given that the magnitude of the kinetic frictional force is 6.5. So we have 6.5 here, and then our mass 100, and then our acceleration, if we read here, we are given 5 meters per second square. So we put 5 there. Then doing your math, you have 100 times 5, that's 500, then plus 6.5. If you transpose the negative, it becomes positive, right? So we have plus 6.5, which is 506.5. Then we need to divide both sides by cos 60 degrees. And then dividing both sides by cos 60 degrees, that means our force now is equals to what? 1013 newtons, right? And just like that, we have found the magnitude of force F. So please pay attention to how I did that one. Okay, then 3.3. Let's proceed to 3.3. It says draw a force diagram. Note, force diagram. So we know most of the time we are used to free body diagram. So it is very important that you read the statement carefully there slowly, and then you highlight the keywords there. So force diagram. So we know that in drawing the force diagram, we need to indicate our box here. So this will be indicating the object. And then what forces do we have? We have the gravitational force, which should always be drawn from the center of the object all the way going downward. So there are rules into drawing this, guys. So this is Fg. And then having to draw your normal force. Your normal force, remember when we define it, we say this is the force that is exerted by the surface on an object that is in contact with. So it always needs to start from the surface here, from the surface in which the object is placed. So if we have to indicate it, this is the surface here. And then our normal force will be starting from the surface going up there. So this is normal force, right? So you need to indicate it like that, 2 marks. So everything needs to be properly drawn there for you to have that 2 marks. So make sure that you observe it carefully there. Now we have 3.4. It says calculate mu k. So let's go to 3.4. Calculate mu k, the coefficient of kinetic friction for the box and the surface. Now we have already covered the steps to this one. I said whenever it comes to calculating the coefficient of kinetic friction or the kinetic friction itself, then you have to always note that you need to start by calculating the normal force. So since now this is being pulled at an angle, we know the formula for the normal force will become Fg minus Fy. So this is the formula that you use if an object is being pulled at an angle. So pulled at an angle, it's Fg minus Fy. So this is pulling because we can see the arrow is outward from the diagram. But then if it was pushed, we know the formula is Fg plus Fy. So this is when it is pushed at an angle, right? So make sure that you know to those formulas because they will not be given in your formula sheet. So you have to know those. If an object is being pulled at an angle, say Fg minus Fy, but if it is pushed at an angle, it's Fg plus Fy. Now this is N is equals to Fg minus Fy. Then it becomes Mg minus F sine theta, right? Now our mass 100 and then multiply by 9.8. Remember the force we've already calculated. We found 1013 and then that's sine 60 degrees. Now at this point, you just want to punch everything into your calculator and then you get 102.72 newtons. So that becomes the magnitude of the normal force. Now, what is it that we need? You will remember from the formula mu k is equals to Fk over N. If we have the normal force, we also need the kinetic frictional force, which we are already given here. So that means we have everything that we need. We just need to write the formula mu k is equals to Fk over the normal force. Now, what is our Fk? 6.5. But our normal force, we calculated it, it's 102.72. Now, punching that into your calculator, that's 0.06, rounded off to 2 decimal places. That's how you were supposed to tackle that question for 5 marks. Remember, with 5-mark question, it is always a case whereby you are looking for something, but before you can calculate that, you need to first solve the unknown there. So you needed to solve for the normal force, and then that's when you can apply that formula. So maybe it would be about 3 marks to do this and 2 marks to do it here, right? Or maybe 2 marks there and 3 marks below. Then let's go to 3.5. 3.5 is asking us a question. How will the coefficient of kinetic friction be affected if the angle of force F is increased to 80 degrees? Right. Note what they're asking. How will the coefficient, not the kinetic friction, how will the coefficient? So if they ever ask about the coefficient, Whether they choose to increase or decrease the angle, this does not affect the coefficient of kinetic friction, because the coefficient of kinetic friction can only be changed by changing the whole surface or by changing the material of the surface. So that's the only way we can change the coefficient of friction. But increasing our angle or decreasing our angle does not do anything to the coefficient of kinetic friction. So our solution for that one should just say remains the same. Remains the same. And that's how you were supposed to tackle this question here for a total of 14 marks. So please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And then if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.